Hello everyone, welcome to my channel. So today we are going to do Leetcode line 75 question, search in rotated sorted array. Let us first in this question, then about the example constraint, and finally the coding part for the same. So let us go ahead with reading of this question. So here, okay, 1 minute. There is an integer array num sorted in ascending order with distinct values. Prior to being passed to your function nums, is possibly rotated at an unknown pivot index k. So here they are just trying to say us that that particular array is rotated, and how it is rotated, from where it is rotated, we are not concerned about the same. We are only concerned that given the array nums after the possible rotation an integer target, return the index of the target if it is in num or -1 if it is not in the nums. So basically, whatever target is given to us, we are required to figure out that target. And after figuring out the target, we are required to return the index of the target. So that's the only thing which we are required to do here. Basically, this is the variation of the question which we have done earlier. Um, that was about finding the minimum element in the rotated sorted array. Here we are required to search for the target in this rotated sorted array. So basically, this is also question of binary search only. Here, while doing binary search, we will be easily able to figure out with the target rather than doing order of n solution. Now we can do this particular in order of log n solution. So that's the thing here. As they have already mentioned that you must write an algorithm with order of log n runtime time complexity. So that's the thing. Now let us first check for the constraint. Then we will be going ahead. Okay. Okay. So here the constraints which are there is nums.length. Here num length is basically up to 5000. Then they are negative and going up to 10 raised to power 4 means basically there could be negative numbers as well and positive numbers as well. And then all the values of num are unique. Nums is an ascending array that is possibly rotated, and target that lies between -10 raised to power 4 and 10 raised to power 4. So basically our element range is from -10 raised to power 4 to 10 raised to power 4, although that is not much concern because we are not multiplying or dividing. But the concern is that they are negative also. And as per the question, it is in sorted order and it is rotated as well. So according to that, we will be going ahead with binary search solution. And as per the length of the this nums, we can easily go ahead with order of n solution as well. But when we are having one more optimized solution, then we can go ahead with that optimized solution as well. So that's the thing. Now let us go ahead with the solution for the same. Here in this first example, our target is 0. So here we figure out the target is at this point and this is fourth index. This is 0, 1, 2, 3 and this is the fourth index. So that's why we are returning 4 here. And that's the thing which we are required to do in every input array which would be given to us. And that's how we will be approaching this particular question. And here if we see this target 3, if we search for 3 it is nowhere. So that's why we are returning -1 as the index. So now comes the part that how we are required to do binary search on the same. So basically, the way we were having the three cases in our previous binary search solution, here also there would be similar test cases. Excuse me, not the similar test cases, but the cases. Uh, just pardon me. Yeah, there would be similar test cases. That would be the scenario here. Now, let us go ahead. So the thing is that we will be checking again like that only means that mid -1 thing which was there and mid was there, right? Like that way only we will be checking for all the three conditions and according to that we will be trying to check get on this particular target. Earlier we were checking for the smaller element, but here we are checking for the target. So accordingly our cases would be modified. So now let me go ahead with the coding part for the same. There directly I'll explain you that what all cases would be there and how they are different from the previous one. So let us go ahead. So here for binary search, we are taking this and then while left less than equal to right. Okay, for binary search and then our mid. Now comes the part. Here, if a target is directly equals to nums of mid, means basically the nums of mid is itself the target. Excuse me. Then we are directly required to return the mid. That's the thing here. Now, if that is not the scenario, if other way around is there, that if our nums of mid is basically greater than nums of right. So this simply means that there are smaller elements towards the rightmost part. The way it was there in the previous question I had explained, right? So like that way it is here. The only condition which is changed here is that here we are not checking for the mid minus one thing. We are directly checking that if target is equals to nums of mid, then we are directly returning the mid. So here if nums of mid is basically greater than nums of right, then we are required to check that if target is basically less than nums of mid and target is basically greater than equals to nums of left. So this will help us to decide that which subarray we are required to take. Here this condition was for the fact that smaller elements are present on this particular portion. But again, we are required to check that if a target is basically smaller than our mid or not. If it is smaller than our mid and greater than or equal to our nums of left, then only we will be moving ahead for this space. Else, we will be moving ahead for the other space. So that's the whole scenario here. Is what I want to convey is, see, this particular simply reflects that a target which is, means say if this is the middle point, right, and this is the left point, and this is the right point. So now we can clearly see that from this point, these are the smaller elements, right? But again, we are required to check that if our target is basically less than mid or not. We can clearly see that our target is basically, means 7 is basically greater than our target, right? So here target is basically less than nums of mid and target should be greater than equal to nums of left. So here target is not greater than nums of left, right? So here this condition won't get satisfied. So that's why here we won't be moving towards this portion. Means this is not our array, means sub array where we are required to check for a target. But other way around would be there. So we will be moving our left towards left plus mid plus one. So that would be the thing here. Is basically this check is required so that we can modify towards a search space. Because in that earlier situation, we were having that the space we are required to check and we are required to check for the smallest element. But here, the element is something else, which we are required to even figure out that is it greater than greater than our middle, smaller than our right, or greater than our left. So that we are required to check. So that's the thing. Here, those elements would be there which are basically less than our right. Means our target should be less than right. So that's why it will hit this particular case. So that's the scenario here. Else if this scenario is also not there, if it's other way around, then we will be checking that if our nums of mid is basically less than nums of left, nums of mid less than nums of left. That simply means that here if our middle is at this point and this is our leftmost point, right? And this is our middle. So this situation completely, what we say, completely agrees upon this condition, right? So that's why then we will be checking if our target is greater than our mid. Earlier we were checking that if a target is less than our mid or not. So here why we are checking for that target is greater than mid so that we can check that if a target is basically greater than mid, then we are required to check here and then we will be checking that if a target is less than right. So it would be in this space. So in that condition, our left is required to be moved here. That's what we are doing here. Else, in the other case, our right is required to be moved towards the forward direction. So that's what we are doing here. Now, the else condition is that if a target is basically less than nums of mid, if that is the condition, then our right wanna be equal to mid minus one, else our left equals to mid plus one. Means basically if any of those conditions which were there means when we were rotating this particular area, so according to that only, all those two conditions were there, and this third condition is in that case when we are not able to figure out with any of the rotation. Means if there is no rotation, it is just a normal binary search. So in that context, we will be directly doing straightforward that if a target is less than nums of mid, so we are required to move towards the left subarray, else we are required to move towards the right subarray. So that's the thing which we are doing here. And then at the end, we are required to return -1 if any of these conditions were never satisfied. So that simply means that the target was not present in the array. And that's why we are required to return -1 at the end. So this is all what we are required to do in this particular question. And now comes the part of the time complexity and space complexity. So as per the space complexity, we hadn't used any extra space, but the time complexity is directly log of n. And why log of n? Because we are directly using binary search, and even we are not again distributing or redistributing any of the content of this particular input. So that's why n is not required to be multiplied with the time complexity of log n. So it is directly log of n solution and space complexity order of 1. So yeah, this was all for this particular question. If you have any doubt, directly comment with the timestamp of that particular portion of the video. I'll reply to the comments of the same. And yeah, this was all. If you like the video, please do like and subscribe to my channel and do share among your friends as well. So this was all. Thank you.